Hi everyone. So today we will discuss the October 2021 Statistics Paper 1. Let's start with the first question. The Venn diagram shows the events A, B, and C and their associated probabilities where P and Q are probabilities. Okay, find the probability of B. So how do we find the probability of B? So what do we know when it comes to a Venn diagram? We know when it comes to probabilities, total probability definitely equals to 1, right? Total probability definitely equals to 1. So how do you find the probability of B? Basically, probability of B means I need to get the probability that falls inside the B circle, isn't it? That means I need to get the value of, I don't need to individually find the values of P, Q here. Basically, I need to know the addition of this P value, Q value, and the 0.3. What happens when I add all these three values, isn't it? What's the answer? So what's the easiest way of getting this? So you can see to get the probability of B, the easiest thing is we get the probabilities outside of B and we subtract it from 1. Is that okay? So I can get the probability of B by doing 1 minus all the probabilities outside of B. So what are the probabilities outside of B? 0.04, 0.06 and 0.4. So from 1 I subtract all these probabilities that are outside of B. Do you agree with my answer? So what do we get for the answer here? So we get here probability of B is 1 minus, there's another, yeah. So what do we get here? Calculate and tell me the answer. So 1 minus 0.5, which gives me 0.5, okay? So actually, if you wanted, you could have gotten this, you could have written the equation as 0.04, 0.06, P plus Q plus 0.3 plus 0.4 equal 1. You could write that equation this where the sum of probability equals to 1 and you subtract and get the P plus Q. And then you get the probability of B by getting P plus Q plus 0.3. That's also correct, okay? Let's move on to part B. Determine whether or not A and B are independent. So how do we find whether A and B are independent? First, I have to get the probability of A. So what's the probability of A? The probability of A is I have to get the addition of the entire A circle, right? So I think it's better if I have the P plus Q probability. How do we get the P plus Q probability? By the sum of the probabilities. 0.04, 0.06 plus P plus Q plus 0.3 plus 0.4 equals to 1, right? All the probabilities, each and every individual probability adds up to 1. Can I know how much is P plus Q? So we add everything. This is 0.1, 4, 5, 6, and 0.8. So all of these are 0.8, right? 0.8 plus P plus Q equal 1, which means P plus Q is 0.2. Okay, so then if I'm going to find the probability of A, probability of A is when I add all the probabilities inside the circle A. So when I add all the probabilities inside circle A, I get 0.04, 0.06 and the P plus Q. Okay, so then let's add everything and get the probability of A. 0.04, 0.06, P plus Q is 0.2. So what is the answer we get here? 0.3. Okay, then get the probability of B also. Probability of B we found 0.5 we got. The next thing we should do is we should get the probability of A multiplied by probability of B, because fine, if two events A and B are independent, if they are independent, then the probability of A intersection B is equal to probability A multiplied by probability B. That is if they are independent. Okay, so then I'll get the probability A into probability B. Probability A is 0.3 into probability B is 0.5. How much do I get here? 0.15. So probability A into probability B, check whether this is equal to the probability of A intersection B. So what is the region that's common to A and B both? A intersection B, I think you can see circle A, circle B, the intersection falls to this, which area? The PQ area, isn't it? PQ, the P plus Q area. So the intersection falls to this area. Do you agree with me? Then I get here P plus Q is the A intersection B. So P plus Q answer we found as 0.2. So what do you see here? Probability A into probability B. Is it equal to probability A intersection B? No. Not equal means what? A and B are not independent. Okay? Okay. Okay, then part C, given that probability C given B is equal to probability of C. I think you should, yeah, probability C given B is equal to probability of C. Find the value of P and the value of Q. Okay, let me erase this. So probability of C given B is equal to probability of C. Do you know what this means? Do you know what this means? So basically, if the probability of C given B, you can see this probability of C given B means given that B has already happened, the probability of C happening. That's what we mean by conditional probability. So B is already happened. Given that B has happened, what's the probability of C happening? And do you see the answer is directly probability of C? So I have this you have been taught in your S1 book. So basically here the probability of C happening, does it depend on B? No, that's why the probability of C happening, given that B has happened, is still probability of C, which means C is not depending on B. These are independent events. So, which means B and C are independent events. Or else, the best thing I can do here is we can use the equation. So, what's the equation for the given that probability? Probability C given B is probability C intersection B over probability of B. Are you aware of this? Is equal to probability of C. So if you want, you can use this equation. This is the formula that you have learned for A given B. Likewise, for C given B, I use the equation probability C intersection B over probability of B. So then probability C intersection B is equal to what? Probability C times probability B. Is that okay? Okay, then let's input our values here. Let's input the values and find the value of P and Q. So probability C intersection B. What's the intersection of the C circle and the B circle? Do you see? So this is the C circle. And over here, this is the circle B. Where do these two circles intersect? Where do these two circles intersect? The intersection is at this region P. Do you see? Small region. So C intersection B is the region that we named as P. Is that okay? I'll shade that in yellow. So this is the intersection of C and B. Equals probability of C. What's the probability of C? The probability of C is the addition of all the probabilities inside circle C, which is how much? 0.06 plus P. Because I'm adding all the probabilities inside the circle C. Then multiply that with all the probabilities inside circle B. So do we know the probability of the circle B? Do I need to specially find it, or did we find earlier? Probability of B was found earlier in question 1, right? Probability of B was found as how much? 0.5. So input C as probability of B as 0.5. Now what? We make P the subject. Make P the subject. P equals. So this bracket you need to open it with 0.5. So 0.5 times 0.06 plus P. Open the bracket. 0.5 into 0.06. How much is it? 0.5 into 0.06 is 0.03. Okay. So I get here 0.03 plus 0.5 into P is 0.5P. So P minus 0.5P equals to 0.03. So I get here 0.3P, isn't it? Sorry, 0.5P. 0.5P equals 0.03. P equals to 0.03 divided by 0.5. How much is it? 0.03 divided by 0.5. I get 3 over 50, which is 0.06. So P value is 0.06. Is this clear? Then how do we get the Q value? We know P plus Q is 0.2, which we found earlier. So Q equals to 0.2 minus the p-value 0.06. Q equals to 0.2 minus 0.06 is 0.14. So this is my P and Q value. This is clear? Okay, so now we'll move on to the next part. Part D, the event D is such that A and D are mutually exclusive. Okay, what do we mean by mutually exclusive events? In mutually exclusive events, the two events, the events A and B, they do not intersect at all. There's nothing common between A and D. Now, do you see the circle A? So when they say circle A and D are mutually exclusive, it means circle A does not by any chance touch circle D. Now circle D is not drawn yet. Okay, now you can see here circle A and circle C, that's intersection. Isn't it? Circle A and circle B also, that's intersection. But they say here A and D are mutually exclusive, means A and D, the circle A, and I'm going to draw another circle called D, and when I'm drawing my circle D, it should not in any way touch circle A. Do you understand? That's what it means by mutually exclusive. Then they say probability B intersection D. B intersection D means what? Intersection means when the circles meet, right? So that meeting point, the probability of meeting, the probability of the intersection is greater than 0, which means what? Greater than 0 means you have a probability. Now if they say probability of B intersection D is 0, it means again B and D also doesn't meet. That means if the probability of the, now basically mutually exclusive means what? Mutually exclusive means probability A intersection D actually is what? Is actually 0. You should know that. When they say two events are mutually exclusive, it means the intersection of those two events is 0. So here they say the probability of B intersection D is greater than 0, which means what? Which means you have a probability there. Which means circle B and circle D are supposed to intersect. So it's just 1 mark they are asking you to show a possible position for the event D. Just to draw the position. Are you supposed to calculate probabilities or do anything? No. So how do you draw your circle D? Is it correct if I draw my circle D outside like this without touching anyone? Now it doesn't touch A, but you can see when I draw like this, it doesn't touch B as well. But they have told that there is supposed to be a part where we touch with B, isn't it? So how should I draw it? One correct question is where you can draw like this, isn't it? The circle D, there is an intersection with circle B, isn't it? So this is one correct way of drawing. Okay, so this is one possible question. Another way, what if I draw my D inside here like this? Is this okay or not? It's okay, right? As long as A and D doesn't touch. And then B and D has intersection. So they have not specified to us what type of intersection it is. So we can draw this as well. What is it that I can't draw? I can't draw what? I can't draw something that looks like this, right? Do you see what's the mistake here? You are touching circle A. So if the circle D touches circle A, then that's not mutually exclusive. So this is wrong. Okay, your circle D should not by any chance touch circle A. So circle D, you have two options. Either you mark like this or you can mark it inside. Any of those two options that I gave are correct. Okay. Okay, question number 2. A large company is analyzing how much money it spends on paper in its offices each year. Okay, so a large company is analyzing how much money it spends on paper in its offices each year. The number of employees in the office X and the amount spent on paper in a year P in hundreds of dollars in each of 12 randomly selected offices were recorded. Okay, so it's really important that you keep track of the units. Okay, so the number of employees is X and the amount spent on paper in a year is given in P, and P is coded for hundreds of dollars. Do you see? So in each of 12 randomly selected offices were recorded. Okay, the results are summarized in the following statistics. Okay, so then they've told you the results. The sigma X is given. So they've given you these summary statistics. They're asking you to find show that SXP is equal to this equation. Okay, how do I get that value? SXP is equal to what? The formula for SXP would be sigma XP minus sigma X sigma P over N, isn't it? Okay, let's get the values here. Sigma XP is given to us. Yes, 2, 3, 4, 7. So these are formulas that you need to remember. They in the book you learn SXY. So I converted the SXY equation with SXP, just replacing the Y with P. Okay. So SXP sigma XP minus sigma X sigma P over N. So sigma XP is 2347 minus sigma X is 93 into sigma P is 273 divided by N. N is, you have 12 officers. N is 12. So what do we get here? How much? When we type it in the cal, we must be getting the show that, isn't it? 2347 minus 93 into 273 over 12. So I get here 925 over 4, or we get the 231.25, which is the exact show that. It's really important that you show these substitutions because it's just 1 mark, and that 1 mark depends on you showing this working. Okay. So make sure you show the working where you show the values, because it's a show that you should not just get the answer, but you should show how you got the answer. Okay. Otherwise, you would lose the 1 mark. Part B, find the product moment correlation coefficient for this data. So if I want to find the product moment correlation coefficient or the R value, what do I need to find here? SXP is given, and I think SXX is given. I need to find what? SPP, because the R value is equal to SXY over root SXX SYY. So here instead of Y we have P. So I have SXP, I have SXX, I have to find SPP. How do I find SPP? Sigma P square minus sigma P whole thing square over N, right? These formulas, you need to have an idea of how to use them. Sigma P square is 6602. 6,602.72 minus sigma P is 273 square over N. N is 12. Can I have the answer here? (6,602.72) minus 273, there's no need for the bracket here, square over 12. 391.97. SPP is 391.97. Okay, so then let's find the R value. So R is equal to SXY, in this case SXP over root SXX into SPP. So basically this is the equation we use, the equation that you are supposed to use. So SXP is written as, it's found as 231.25. Root SXX is given to us 148.25. Into SPP is given as 391.97. So calculate this. How much is our R value? What's our product moment correlation coefficient? 231.25 times root 148.25 into 391.97. Okay, so I get here R equals to 0.9593, something like that, right? 0.959307. So basically 3SF.959. This is our product moment correlation coefficient. Are you clear on that? Okay, part C. Find the equation of the regression line of P on X in the form P equal A plus BX. Okay. So they've told you to get the regression line of P on X. So how do we find our A and B values? How do we find our A and B values? B is normally we write B equal normally SXY over SXX, isn't it? That's the equation that I'm remembering. But now in this case, we understand the Y is not Y is replaced by P. So our dependent variable here is P, right? The dependent variable, the number of employees in the office is our independent variable, and the amount spent on paper in a year is the dependent variable. Okay, so then B equals to SXP over SXX. First thing is you must be able to write the equation correctly. So SXP is found 231.25 over SXX was given 148.25, isn't it? Okay, then let's get a value. $231.25 divided by 148.25. I get here. First, I'll write my fraction 925 over 593, which gives me B equals to, the decimal figure is 1.55 9865. Yeah. So basically, this is the full answer. Okay. So then it's better that we have the exact answer as well to help us. So this is anyway the B value to 3SF is 1.56. Okay. Then the next one, the A value. What's equal to A? A equals, normally we have Y bar minus BX bar. Okay, so that's the equation I remember, Y bar minus BX bar. In this case, Y is P. So P bar minus BX bar. So P bar is the average, the mean of P. So how do we get P bar? Sigma P you should divide by N. Sigma P over N is P bar. Do you agree? So P bar is sigma P over N minus B times X bar is also sigma X over N. Do you agree with me? So sigma P is given to us as 273, N is 12. Minus, now in here, it's really important that when you input your B value, do not input the, just don't input the 1.56 here, but do give what? Do give the exact figure. Okay, for B, give the exact figure. Do not give just the rounded off figure. Let's use the exact figure here. Okay. So B is 925 over 593. Otherwise, your A value would not be correct to 3SF. Okay. So give the exact figure. Try to get the answers exactly as much as possible. Into sigma X. How much was sigma X? 93. Over N is 12. Get me the A value. 273 over 12 minus 925 over 593 into 93 over 12, which gives me 6322 over 593, which when I write it to the significant form, significant figures, 10.6610. 45, so something like this, 10455. Okay, so then correct 3SF, it's 10.7. Okay, so when you're writing your regression line, so your regression line would be written as P equals A plus BX, right? P equal A plus BX. So P equals A value is 10.7 plus B value is 1.56 times X. Okay. Next part, part D, given interpretation of the gradient of your regression line. So how do we interpret the gradient? So when it comes to gradient, I have given you kind of like a format that you need to use. So what's the format we use? Normally we say to interpret the gradient when X increases by 1 unit, Y increases by the gradient. So now who is our X and Y here? X is the number of employees, right? The number of employees in the office. So and then the P value, the Y value is the amount spent on paper in a year. So what does that mean? The amount spent on paper in a year, and it's in hundreds of dollars. So what do we understand here for our gradient? So when X increases by 1 unit, which means X is the number of employees. So what does it mean? When X increases by 1 unit, Y increases by the gradient. So then for what? For each new employee or for each extra employee, for every new person, for every employee that we take, what happens? When X increases by 1, this is basically when X increases by 1, Y increases by the gradient. Who is Y? P is the amount spent on paper. The amount spent on paper for a year. What increases or decreases? Positive gradient means it's increasing. The amount spent on paper for a year increases by how much? 1.56 is, now they have told you the amount spent on paper is measured in what? Hundreds of dollars, right? The amount spent on paper, they've told you very clearly, the amount spent on paper is measured, the P is measured in hundreds of dollars, which means what? 1.56, the real value is what? 1.56 is coded. So it should be, it increases by $156. So for every extra employee, the amount that they spend for paper in a year increases by $156. Okay. This 156 came here from this 1.56 over here. Okay, the 1.56 is, that means when x increases by 1, this p value increases by 1.56. However, the p value, the amount spent on paper is measured in hundreds of dollars. So because of that 1.56, we can, the proper answer should be 156. Okay, so for each extra employee, it costs the company $156 a year. Okay, shall we move on to the next part? Okay, part E. The director of the company wants to reduce the amount spent on paper each year. He wants each office to aim for a model of the form B equals 4 over 5A plus half BX, where A and B are the values found in part C. Using the data for the 93 employees from the 12 offices. Okay, estimate the percentage savings in the amount spent on paper each year by the company using the director's model. Okay. Now they are asking, now obviously this model is given for what purpose? This model, the director is giving this model for the purpose of what? For saving the cost that you're spending on paper. Okay, so that's why this model is introduced. So they are asking you, comparing this model with the previous model, how much are we actually saving? That's what they are asking. Estimate the percentage saving. So first of all, what we'll do is, let's say how much did we spend on paper in the previous model? In the previous model, can I know an estimate for the like, now there are 12 officers, right? So what was the amount we spent on paper averagely? We could say averagely we spend how much money each office? So you have, this is the amount you spend on paper, right? 273. So in the previous model, we can take the P bar value. The amount averagely we spent on paper is 273 over 12. How much is the answer? 207. How much are we spending on paper? Which is 22.75 in hundreds of dollars. Right? 22.75 hundreds of dollars. Okay. So then what about the new model? Okay. So in the new model, let's find. In the new model, first let's find our new model. P equals 4 over 5A. What's our A value? A value was found as 10 points. Now don't just use the 10.7. Okay. Now when you're continuing this sum, it's better that you use the large value. 10.66, or better that you go with the exact figure. What's the exact figure? 6,322 over 593. I'm using the exact figure for A. Okay. So when you're continuing, please use the exact figure. Make sure you use the exact figure. So P equals 4 over 5A plus half into B. B also use the exact figure. Don't use 1.56. Use 925 over 523. 925 over 593. B into X. Okay, so this is again this is the director's model. So in this model, how do I find the average, the amount spent on paper? So for X, what do I need to use? Again, for X is the number of employees. We'll use the number of employees here as what? Sigma X is 93, the total. So we are going to find the average. So basically, I'll use, what will I use here? I'll use here half into, okay, use the value X. I will use 93 over 12, the average. Okay, so let's get the average amount that we spend in the new model. So previous model, I have the average amount we spent. From the new model also find the average amount that you are spending. Calculate this answer. Okay, so when I type this in the cal, I get 14.5733. I mean, I get a figure like this. Okay, so use this figure 14.5733. Okay, so you get this full figure. Which can I make it to a decimal? No. 14.5733. Okay, so then let's now take the percentage saving. Okay, so here I'm taking from the previous model also, I found the average amount spent. So from this model also, I should take the average amount. That's why I use X bar here and I got the average amount spent from the new model as well. So you can definitely see that the new model has the reduced. It has reduced the amount spent on paper. So now I have to find the estimated percentage saving. So percentage saving. How much are we saving? The saved amount over the original amount into 100. So saved amount is 22.75. We subtract from the 14.5733 divided by the original value is 22.75 into 100. So it's best if you could use all the decimals here. Okay, it's best if you could use all the decimals here. So I have the answer stored in my cal, so I'll directly go with 22.75 minus answer because it's stored in the cal. Okay, 22.75 minus answer over 22.75 times 100. And I end up getting here 35.941. Do you see? 35.941. Which means when I round it to 3SF, 35.9% or 2SF, 36%. Okay, so this is the percentage saving that we get for paper by using the director's model. Question number 3. The stem and leaf diagram shows the ages of the 35 male passengers on a cruise. So they've given you the age and they've given you the key. The key tells you how to read this stem and leaf diagram. So here 1 and this 3 represents an age of 13 years. Okay. So then remember you need to get the stem and leaf together to read the stem and leaf diagram. They're asking you part A, find the median age of a male passenger. Okay. First thing is, this is what data are we dealing with, discrete data or continuous data here? We are dealing with discrete data. They've given you the ages of every single passenger separately, isn't it? So question number 3, part A, the median age. How do you get the median? The equation for median we use is n divided by 2, isn't it? If n divided by 2, if we get a whole number, we round that number up. That's the method we learned in the S1 textbook, right? In the textbook, they say if you get a whole number, then you should, if you get a whole number, take the midpoint of that term and the term above. But if you get a decimal answer, just round it up and get the corresponding term. So what's our n here? Can you all calculate? Add everything here. There are 35, right? When you add everything here, how much do we get? Add everything, how much do we get? 35. Is that okay? 35 divided by 2. What is the answer? 17.5. So you get a decimal figure. So when you get decimal figure, what have we told you? You must round the number up. So when you round the number up, the 17.5 becomes 18, and 18 is not the median. The 18th term, when you arrange your data in ascending order, the 18th figure is the median. Okay, so then let's count and take it. So here there's 1, 2, 3. So here there's 3 terms. 3 plus 4. Here there are 7 terms. Do you see? I'm adding the values they have given in each row. How many data points are there? So then 7 plus 7 is how much? 14. So it's, I think you can see this is 14. The next one is 24. So basically, if you have 14 terms until this point, if you have 14, so this is 15. This is 15, 16, 17. This is the 18th term. Do you see? The one that I rounded, the one that I circled. So this is the 18th term. Do you understand? Because until this point, we have 14 terms. Then this is the 15th, 16th, 17th. This is the 18th one. Is that clear? So median is 53. Part B, show that the interquartile range of these ages is 16. So it's a show that, which means you must first get your Q1 and Q3. What is Q1? N divided by 4. N is 35 divided by 4. What is the answer? Tell me the answer quickly. 35 divided by 4 is how much? Like, wait, 30 divided by 4. Not hearing what you all are saying. Okay, 8.75. So 8.75, you must round the number up. So when you round the number up, it's the 9th term. So 9th term count. So here the first 1, 2, 3, 4, 5, 6, 7. So you can see 7 is ending here. 7, 8, 9. So 9th term is 45, right? Q1 is 45. Do you agree? Q3 is 3n over 4. 3 times n is 35 divided by 4. How much is it? 26.25. When you round up, 27. So best that you keep going here. So until here, this point there are 24. So go from here 25, 26, 27 is 61. So interquartile range, Q3 minus Q1. 61 minus 45, which gives me 16, and which is the show that. Okay, do you understand? The next part, an outlier is defined as a value that is more than 1.5 times IQR above the upper quartile and 1.5 times IQR below the lower quartile. Show that there are 3 outliers amongst these ages. Okay, so how do we find the outliers? So the upper fence or the upper boundary. The upper fence for the outliers are, so Q3 plus 1.5 IQR, isn't it? When you read it, do you realize it? So these are things that you need to be trained in the book. So they say the outlier is a value that is more than 1.5 times IQR above the upper quartile. So Q3 above the upper quartile means Q3 plus, above means plus, and we add the 1.5 times IQR. Can know the how much is the upper fence? Q3 is 61 plus 1.5 times interquartile range is 16. How much is the upper quartile? 85. Get the lower fence as well. Q1 minus 1.5 times IQR. Q1 is 45. 1.5 times interquartile range is 16. How much do we get here? 21. Okay, so now if any of your data points are falling between the upper fence and lower fence, those are inside the range. But if there's any value who is outside, who is above the upper fence or who is below the lower fence, then those are outliers. Okay, let's check the outliers. So at the beginning, the first value I have is 13. So you can see here my lower fence is 21. 13 is lower than 21, which means what? 13 is an outlier. The next value is 27. Isn't it? 27 is an outlier? No, because it's more than 21. The boundary is at 21. Anything below 21 is an outlier. Okay, 21 or more, it's inside the data set. Similarly, the upper fence is 85. So you can see we have what are the terms that are bigger than 85? 73, 76 are inside, then 87, 88. You see? So you can say outliers are greater than 85 or outliers are less than 21. So what are the outliers? So your outliers are 13, 87 and 88. These are your outliers. Okay. Okay. Then show that there are 3 outliers. So there are 3 outliers. Okay. Then let's move on to the next part. Okay. On the grid in figure 1 on page 9, draw a box plot for the ages of the male passengers on the cruise. Okay, let's draw the box plot. So we have all our information. Let's draw it. Okay, so part D, on the grid in figure 1 on page 9, draw a box plot for the ages of the male passengers on the cruise. So I've taken the box plot over here. So then they are asking us to run. They have given here the summary data for the male passengers, right? They are asking us to draw it on a box plot. Okay, so what do we draw on the box plot? Normally, this box, the two points, the two corners are the the lower quartile and the upper quartile. What was our Q1? Lower quartile Q1 was 45. Okay, so then draw the line. Let's draw it. The lower quartile is at 45. Okay, and then what's the upper quartile? Where is it? 61. So 61 is somewhere like over here, right? Okay, so then this is the first part of the box. 45, 61, and then the median 53. So 50, 51, 52, 53. So make sure you do it very accurately. Is this correct? 50, 50, 51, 52, 53. Yeah. So this is 53. And then in your box plot, the next important thing are the two whiskers. So when you draw your whiskers, now the most probable way of drawing, the best way of drawing your whiskers is where you mark the outliers we mark with the crosses, and for the whiskers we start with the lower whisker, we start with the lowest value that is not an outlier. Now what's the lowest value here? Who is not an outlier? 13 was an outlier, isn't it? We identified 13 to be an outlier. So let me mark 10, 11, 12, 13 is an outlier. Right? 13 was an outlier. So then who is the next value who is not an outlier? 27. Okay, so then some of you draw it with the upper fence, lower fence, but normally the correct way of drawing this, because the whole data set is given. Now, do you see the entire data set is given to you? When the data set is given to you, it's best you use the exact figures that they give you. So then in this case, the next value who is not an outlier is 27, which is an exact value in our data set. So go to 27. So 27 is somewhere up over here, right? So 27, 28, yeah. And then draw the whisker from 27. Okay, so this is the whisker, the first one. The second one, I think you can see 87, 88 are both outliers. So 87, 88 are both outliers. 87, 88, both are outliers, right? 87, 88 are both outliers. Draw it properly. 87 and 88 are both outliers. Okay, and then the box plot, who is the biggest value, who is not an outlier? The largest value who is not an outlier is 76. So then you start your whisker at 76. 76 somewhere over here, right? From the box plot, 76 I get it from the box plot, because 87 and 88 are outliers. The next biggest value who is not an outlier is 76. Okay, because it's inside the upper fence. Okay, so the upper fence was 85, so 76 is the first value who falls underneath that. The biggest value in our data set who is not an outlier is 76. So I start from there. So this is my box plot. Okay, are you with me? Okay, part D. Part D we just did. Part E, let's go. Let's go to part E. Figure 1 on page 9 also shows a box plot for the ages of the female passengers on the cruise. So you can see the box plot that gives you the data about the female passengers. Comment on any differences in the distributions of ages of male and female passengers on the cruise. State the values of any statistics that you have used to support your comment. So they've just given you 1 mark. So what's the best comment that you can give? For 1 mark, you can give 1 comment. Compare in the 2 box plot. So what is the main statistic that you can compare here? What is the main statistic that you can see that you should compare? Basically in here the Q, you have here the box plot starts with Q1, the middle line is Q2, this is Q3, right? Okay, So this is Q1, Q2, Q3. So basically the best person to compare here is what? The Q2 is what? There's a special name for Q2. The median. Q2 is the median, isn't it? You arrange your data in ascending order. Q2 is the median. So then the best person here, the easiest one that you can compare here is the median. So what can we say about the median? Now they just want you to comment on it, any difference in the distribution of ages of the male and female passengers. So what do you say about the median? What do you notice? The median age of the the median age of the males are or else you can say the median age of the females are higher, or it's the females are generally older than the median of the males. So write down and then give the values. They ask you to state the values as well. So you must give it with the values. So part E. The median age of females is higher than that of the men. The median age of females is higher than that of the men, and you must give the statistics. So what is the statistic? Female median age was how much? 67, which is higher than how much? 53. So 67 more than 53. So they ask you very clearly to give the statistics that you have used. So make sure you give the statistic. You can include it in the statement here, or you can write it like this. Make sure you mention these two values. Okay, so the question is in part you asked me, like, can't we use other different statistics? So you could talk about the spread. The spread of data, the interquartile range. You could talk about the skewness. Yeah, you can do all this, but make sure that you show your supporting working, because they ask you to find the values. You must support your answer by with the working. Okay, so you can use any of those statistics. It's fine, but make sure you show the working. Okay, let's move on to part F. Anja, along with her two daughters and a granddaughter, now joins the cruise. Anja's granddaughter is younger than both of Anja's daughters. Okay, Anja had her 23rd birthday on the day her eldest daughter was born. When their 4 ages are included with the other female passengers on the cruise, the box plot does not change. Okay, so this is the important thing. The box plot doesn't change at all. So they ask you, state giving reasons what you can say about the granddaughter's age and Anja's age. Okay, so this is really important. The another thing is there are 4 passengers who are joining the cruise, isn't it? Now previously we had this female box plot. Do you see the female box plot here? So this was given for the females who were there in this cruise. Now they are adding 4 new additional passengers. So Anja, her 2 daughters and her granddaughter. So that means we have 4 new female passengers. There are 4 new female passengers. So when they join this cruise, so their data, their ages also get added to the list. So when they add it to the list, they are saying that there is absolutely no difference in this box plot. So now you need to think, okay, how come there is no difference? Why would there be no difference in a box plot? So then if there's no difference, then what can we say about the granddaughter's age, and what can we say about A's age? Okay, I'll say A here. Okay, so how can we understand this? How can we figure out how to put these ages and where to put these ages? The first thing you need to understand here is you need to realize what are the conditions you require to have no change in the box plot. Let's take a simple example. So to go for this, first I'll describe it with a simple example. Let's take a simple data set. Okay, this is something a little bit outside, because to teach this, I want to show you a small example. Say I have a data set in this order 1, 5, 7, 8, 10. Let's take a small data set. Okay, now this is a data set with only 5 values. So this is something outside of this paper. Okay, I just want to show you how these medians, these interquartile ranges, how they will not change. Now in this data set, what is the median? In this data set, who is the median? 7. All of you can clearly see 7 is the median, isn't it? Okay, now let's say into this data set, I'm going to add 2 more values. Okay, I'm going to add 2 more values. So let's say I'm going to add the extra values. Say I'm going to add one is 4 and the other one is 9. I'm going to add 4 and 9. Now, you know, when you're adding data to a original data set here, does it go anywhere it wants? No, we always arrange our data in what order? In ascending order. Now, what happens? I'm adding 2 more data points into my existing data set. What happens when you arrange now? It's going to be 1, 4, 5, 7, 8, 9, 10. So these 2 new points are coming to these 2 places. Do you see? 4 and 9 are now included. Okay, now check the median. Check the median. Does it change? No, right? Do you see the median is still 3 here, 3 here? The median is still the same. So do you see I have added 2 extra values and yet my median has not changed. So what is the requirement now in here? Now, okay, let me show you like this. Let's say to this same question, I'm asking you to add 9 and 11. So I'm asking you to add 9 and 11. Now what happens? You add 9 and 11, rearrange the data set 1, 5, 7, 8, 9, 10, 11, right? Because the 1, 5, 7, 8, the 9 comes here, 10 and 11 comes afterwards. Now what happens? Is the median the same or is it changing? Okay, I'm arranging the previous data set, this old data set for this one. I'm adding the 9 and 11 to this data set. Okay, so these are 2 different examples. These are 2 different examples. So for this example, when I add 9 and 11, do you see it becomes 1, 5, 7, 8, 9, 10, 11. Now what happens? The median has changed. Do you see the median has the median has actually increased? Can you see the median has increased? So now, I want you all to understand what's going on here. In the previous way, in the first method, when I added the 2 values, the median didn't change. But in the second method, when I added, the median actually what? Increased, decreased, or stayed the same? The median increased. Okay, can you all see the mechanism that works here? So when you have a current value, now let's say we have our median, now our median was 7 in this data set. So in the first part, I added a value, one value was less than the median, the other value was more than the median. Do you see 4 is lesser than the median, current median, 9 is more than. So then when I input this value into the data set, then one value falls behind 7, the other value falls after 7. Therefore, what happens? The median will not change because the median is counting the position, right? It's the position. So if you put 1 before and 1 after, the median for the person doesn't change because you put 1 before, 1 after. So it's still symmetric around that point. Do you get what I'm saying? So now, do you see in the other example what happened? 9 and 11, when I input 9 and 11 into this data set, 9 and 11 are both above 7. So when 9 and 11 are both above 7, what happens? The median 7 will increase. The median 7 increases, it goes to the next value. Do you see what happened here? So now this is the theory we need to use here. So they are saying here, now they are adding 4 passengers to this cruise, right? All of you, do you realize the theory here about not changing? The theory of not changing is if the box plot or any of the median and quartiles doesn't change, it means you need to have values falling on either side of your box plot, on either side of the median, on either side of the Q1, on either side of Q2, and either side of Q3. Then those values will not change. Okay, let's see. Now they say here A along with her 2 daughters and a granddaughter now joins the cruise. A's granddaughter is younger than both of A's daughters. A had her 23rd birthday on the day her eldest daughter was born, which means what? So when A had her 23rd birthday on the day her eldest daughter was born, means A is 23 years older than her elder daughter, isn't it? A is 23 years older than the elder daughter. Okay, so that's the age gap. Basically, you have the age gap between A and her elder daughter. When their 4 ages are included with the other female passengers on the cruise, the box plot does not change. Now, this does not change theory will include what I told you just now. So, so you have 4 passengers to include in this box plot. There are 4 things to include, and then if the box plot doesn't change, what do you understand? If the box plot doesn't change, what do you understand? So then now see your current Q1 shouldn't change, which means what? One age will be below the Q1, the other age should be above the Q1. If Q2 doesn't change, one age should be below the Q1, the other age should be above the Q1. If Q3 doesn't change, one age should be below the Q1, the other age should be above the Q1. If Q4 doesn't change, one age should be below the Q1, the other age should be above the Q1. If Q5 doesn't change, one age should be below the Q1, the other age should be above the Q1. If Q6 doesn't change, one age should be below the Q1, the other age should be above the Q1. If Q7 doesn't change, one age should be below the Q1, the other age should be above the Q1. If Q8 doesn't change, one age should be below the Q1, the other age should be above the Q1. If Q9 doesn't change, one age should be below the Q1, the other age should be above the Q1. If Q10 does below the Q2, the other age should be, another age should be above Q2. And if Q3 doesn't change, one should be above below Q3 and above Q3. Do you realize what's happening here? Okay, now let's place the 4 ages. Okay, so then the important thing that you realize here is that the four passengers, if there are no changes happening, each passenger, you get one passenger on each section here. Do you see? So then there will be absolutely no change to the box plot. Okay, so then you should get one passenger in each section. So then who do you think is now? You can see the ages, the youngest one. So do you see where is the youngest one falling? The youngest one should be Anja's daughters or granddaughters, obviously. The youngest age should be the granddaughter. The oldest age should be the grandmother, which is A. Who is A? These are the two daughters. Okay, so then they are asking you the range, that the range of the granddaughter's age and the range of A's age. So what is the range of the youngest daughter's age? The granddaughter, what's the range of the granddaughter's range? So you can see obviously the smallest value here, the youngest age here should be the granddaughter, which is fall in which range? It falls to this particular range, right? And you need to realize that it doesn't go behind 34, because if it goes behind 34, it will become an outlier, which will make a slight difference. At least it will make a difference to the box plot, because you'll have another cross if the granddaughter's age is behind 34. So what do we realize here? So in part F, Roman number 1, we realize the granddaughter's age is what? The granddaughter's age is in the range between what? 34 to 51. It's between 34 and 51. Sorry, not 51, 56. Sorry, 56. Because the Q1 ends at 56. So the granddaughter's age can be anywhere inside this gap. Okay, and then the eldest daughter is going to come in between Q1 Q2. Then the second the younger daughter comes here. Then the eldest daughter comes to this range, and then Anja's age. Now this you have to be a little bit careful. So this is the grandmother, the oldest person here. So when you tell her age, there is an extra piece of information they've given you. They have given you an extra piece of information. They have told you that that she is what? 23 years. Now the eldest daughter was born on her 23rd birthday, which means A is 23 years. I mean, at least 23 years above the eldest daughter's age, right? Okay, so she is 23 years above the eldest daughter's age. Now, can you all think, guess and tell me to which range the A's age should fall? What should be the range of A's age? Think about this. Okay, so we understand now. They've told us that A is 23 years older than her eldest daughter, isn't it? She's having an age gap of 23 years with her elder daughter. Like that's the age gap. Now we know the elder daughter is in which range? The elder daughter is in the range of what? The elder daughter. What's the range of the age of the elder daughter? How much? Q2 to Q3, which means Q2 starts at 67, ends at 72. Isn't it? So this is the age range for the elder daughter. Now we know that Anja is what? 23 years older than her. So if she's 23 years older than her, what can age range be? Age age, if the elder daughter is 67 years, then 23 years plus 67 is how much? Because she's 23 years older than the elder daughter. So the lowest value for A's age falls to 90, which is definitely in this region. Do you see it? It is definitely in this region, 90. And then age 90, what about the other one? The highest value of the elder daughter can be 72. So add 72 and add how much? Add 23 to 72. 95. So 90 to 95. However, now they have told us that the box plot, is it changing or not? The box plot doesn't change. Now you saw that the lowest value that A can take is A's lowest age is at 90. The lowest age that A takes is 90. That is when the elder daughter is 67. That's the lowest age for the elder daughter is 67. Then lowest age for A is 90. Are you with me? Then the highest age the elder daughter can take is 72, which means the highest age that A can take is 95. However, if you take 95 in this box plot, they tell us the box plot doesn't change. Do you see if A's age becomes 95, the box plot should change, né? Because 95 comes to here, it will be different. So because of that, what do? The box plot, they say the box plot doesn't change, which means what? The highest value that she can take is actually what? Not 95, but 93. 93 from the value here. So this is the highest value that A can take. Do you understand what's going on? So then here A's age, Anja's age is in the range 90 to 93. So this is the range of Anja's age. Okay, so this is the important thing. Question number 4. 3 bags A, B and C each contain colored balls. Bag A contains 4 red and 2 yellow balls only. Bag B contains 4 red and 1 yellow. Bag C contains 6 red only. In a game, Mike takes a ball at random from bag A, records the color, places it in bag C. He then takes a ball at random from bag B and records the color and places it in bag C. Okay, so then they take the balls that you're taking are taken from what? Bag A and put to bag C. Again, you're taking from bag B and you put to bag C. Finally, Mike takes a ball at random from bag C and records the color. Complete the tree diagram on the page opposite to illustrate the game by adding the remaining branches and all probabilities. So I brought the tree diagram on the other page over here. Can you figure out what's going on? What's happening here? Okay, so you're supposed to complete the tree diagram basically. Now they are saying again, so you have 3 bags. Bag A has 4 red and 2 yellow. Bag B has 4 red and 1 yellow. Bag C has what? Bag C has 6 red only. Okay, do you see what's going on here? So have an idea what's going on. Okay, now they say you take a ball from the bag A, then you take a ball from bag B, and all of these are going to bag C. Do you understand? Whatever you take from bag A goes to bag C. Whatever you take from bag B also goes to bag C. Now in the first part, they've said it's in the first part, bag A, they've taken a red. Okay, so you can see 2 chances out of 3. Do you see how you get 2 over 3? Because why? The total here is 4 plus 2, total is 6, right? Here 4 plus 1, total is 5. So when you take to the chance of getting a red is 4 chances out of 6, which is in other words 2 over 3. And again to take a red from bag B, you can see we have 4 chances out of 5. So which means from both bag A and bag B, I've taken 2 red color balls, which means what? Bag C. Now before I go to take a before I take a ball from bag C, you need to realize whatever I took from bag A is going to reach here. Which means what now? In bag C, what are the options I have? In bag C, what do I have now? From bag A, I have taken red. From bag B, I took a red. Or both of these reds come over here, and you have another 2 extra reds in bag C right now. Do you understand? So in the third option, what do I get from bag C? Do I get both red, yellow? Do I get both red, yellow? No, I think you can see bag C, definitely I'm getting red. I'm definitely getting red. The probability is 6 out of 6, or basically the probability is 1. 6 out of 6, because it's not 6 out of 6, 8 out of 8. 8 out of 8. Because the total is 8 and all are red. So that means you only get the option red, right? It's obvious, you only get red. Likewise, let's do the next one. Continue and complete the tree diagram. In the next branch, from bag A, I'm taking a red. From bag B, I'm taking yellow. What's the probability of taking yellow from bag B? 1 out of 5. And then, from bag A, we take a red. From bag B, we take a yellow. So these red and yellow are now in bag C. Okay, so what's the probability that I can take? Okay, but we have 2 options here. So I can take a red bead. Or I can take a yellow. So red, what are the chances I have? There's 6 red and there's 1 extra red that I'm bringing here and 1 extra yellow. So altogether 6, 7, 8. There are altogether 8 balls. Out of them, how many are red? 6 red inside, the 1 red that I brought from the bag A. Altogether, how many reds are there? There are 7 reds. So 7 out of 8. And then to get a yellow from bag C, I have 1 chance out of 8. Do you understand? Then the next one. Let's going back to bag A again from the very beginning. Remember, each of these branches, when you go from the beginning, you have to think of it new. Okay, so starting again from the first one. Bag A, what's the chance of you taking a yellow ball? You have yellow, you have 2 chances. 2 out of 6, isn't it? 2 out of 6 becomes 1 over 3. Okay, then from bag B, we are going to take a red. From bag B, we take a red. What's the chance of taking a red from bag B? 4 chances out of 5. Okay, so now what are we introducing to bag C? From bag A, we are taking a yellow. And then from bag B, we are taking a red. So altogether, what are the options I have in bag C? So either it's going to be a red or it's going to be yellow. So what are the chances that I take a red here? 6 plus 1, there are 7 red out of 8 and the yellow we have 1 out of 8. Do you understand? Is this clear? Okay, so again, what is the thing here is now we are, if we go along this branch, from bag A we take a yellow. Okay, that yellow ends up in bag C. Okay, and then from bag B I take a red. From bag B taking a red is 4 out of 5 chances, the probability that red also end up in bag C. So now in bag C, in addition to the 6 red beads, you also have 1 yellow which came from bag A and 1 red which came from bag B. Do you understand? So now altogether there are 8 beads. So the chance of taking a red bead from bag C is 7. There are 7 reds. 7 out of 8, and from the yellow, for yellow I have 1 chance out of 8. Okay, shall we continue? So let's continue with the last branch. I'm erasing this and writing it for every branch. For bag C combination, I'm writing it for every branch. So starting bag A, I'm taking a yellow. From bag B, what's the chance of me taking a yellow? 1 over 5. So that means what? From both bag A and bag B, I'm taking a yellow, which means what? We get 2 yellows. We get 2 yellows now. Are you with me? So then what are the chances of you taking a red bead from bag C? 6 over 8, which can be simplified as 3 over 4, right? Yeah, and then the other one, the yellow we get 2 over 8. Yeah, yellow 2 over 8. Okay, so you can simplify and write the fractions. Okay, so this is it. Okay, shall we write the simplified fractions? 6 over 8 is 2 over 3 over 4. 2 over 8 is 1 over 4. Okay. Okay, so then we'll move to the next part. Show that the probability that Mike records a yellow ball exactly twice is 1 over 10. Okay. Show that the probability that Mike records, okay. In a game, Mike takes a ball at random from bag A, so records the color, places it in bag Z. He then takes a ball at random from bag B, records the color and places it in bag C. Finally, Mike takes a ball at random from C and records the color. So basically, what is this recording? The recording the color is whatever Mike takes out from each of these 3 bags. Do you hear me? So whatever he takes out from bag A, he records the color. When he takes out from bag B, he records the color. When he takes out from bag C, he records the color. End of the day, they say, show that the probability that Mike records a yellow ball exactly twice. So a yellow ball is recorded exactly twice. The probability you should show it's going to be 1 over 10. How do we show it? So you have to consider all the cases in the tree diagram where you get what? Where you get a yellow ball twice, exactly twice. What are the branches that has exactly 2 yellow balls? So what are the branches? Let's consider this was part A. Part B, what are the branches? Can I take the first branch? Red, red, red. No. The next one, red, yellow, red. No, there is 2 red and 1 yellow. So to have exactly 2 yellow, I can take red, yellow, yellow is one option. That's one option. Plus, what are the next options? Yellow, red, yellow. Yellow, red, red also doesn't work. Yellow, red, yellow is another option. And then yellow, yellow, red is the last option. You see, yellow, yellow, red is the last option. So these are the 3 paths where you have what? Exactly where Mike records exactly 2 yellow balls. So multiply the probabilities along each branch. Red is 2 over 3 into go. Now you understand each branch, right? You understand red, yellow, yellow is this. 2 over 3 into 1 over 5 into 1 over 8. Plus yellow, red, yellow, yellow is 1 over 3. Red is 4 over 5 into yellow is 1 over 8. Plus yellow, yellow, red. Yellow is 1 over 3 into yellow is 1 over 5 into red is 3 over 4. Is that okay? Yellow, yellow, red. So let's multiply. Simplify, get me the answer. Add everything, give me the answer. So you should be able to get what? The answer when you type in the cal, you must get 1 over 10. 2 over 3, 1 over 5 into 1 over 8 plus 1 over 3 into 4 over 5 into plus 1 over 3 into 1 over 5 into 3 over 4. So I should get the answer. Do you see I get 1 over 10? Which is a show that. So let's move to the next part. Okay, given that the word itself tells you, what is it? When you see the word, the moment you read it, when you see the word given that, it means it is conditional probability. Given that Mike records exactly 2 yellow balls, find the probability that the ball drawn from bag A is red. So given that probability is how do we write? Probability, the given that should come after the line. So find the probability that the ball drawn from bag A is red. So from bag A we get red. Given that what? Given that there are 2 yellow balls. So 2 yellow balls. How do we open this kind of thing? How do we open this kind of thing? So in given that A given B, we write probability A intersection B over probability of B, right? In probability A given B, the way we open it is probability A intersection B over probability of B. Do you agree with me? So here I have probability bag A and red. Bag A is red and you have 2 yellow balls divided by the probability of 2 yellow balls. Okay, so how do we do this? Bag A has a red ball and you need to have 2 yellow balls altogether. So which path are we talking about? From bag A, you should get a red ball. And when Mike records, he should also have on the path 2 yellow balls. So which path is this? This path is definitely the red, yellow, yellow path, isn't it? Because in that path only, the first bead is red and the others remaining are yellow. Red, yellow, yellow, isn't it? And then I already have the probability of 2 yellow balls, which we found what? In part, the answer we found in part B. So red, yellow, yellow probability we have here. 2 over 3, I think I have written here. Yeah, red, yellow, yellow probability is written here. 2 over 3 into 1 over 5 into 1 over 8 divided by 2 yellow balls. The probability is 1 over 10, which we found in the earlier part. Simplify this and give me the answer. What do we get? Two over 3 into 1 over 5 into 1 over 8 divided by 1 over 10. 1 over 6 is our answer. Is this clear? Okay, then next part, Mike plays this game a large number of times, each time starting with the bags containing balls as described above. Okay, so he does this game, the same game. What's the game? You start off with bag A, bag B, bag C, and every time you take a ball from bag A, you take a ball from bag C, and you put both of them to bag C, and then you take one counter again from bag C. So he does this experiment a large number of times. The random variable X represents the number of yellow balls recorded in a single game. Then game what's happening here? They are telling you X represents the number of yellow balls recorded in a single game. So in a single game, basically you can see this tree diagram is given for a single game, right? This tree diagram is drawn for a single game. So in a single game, the X represents the number of times you record a yellow ball. And they are asking you what? Find the probability distribution of X. So probability distribution means what? How do we create probability distribution? Do you remember? So you have your X value and you write the probability of each X value, isn't it? So here X represents what? The number of times you get yellow in a single experiment. So what are the values that we get here? Look at your tree diagram. So it guides you. Tell me. So what are the branches that we have? So for example, what's the number of yellow we can take in the first branch? In the first branch, what are we recording? From bag A, we record red. From bag B, we record red. From bag C also, we record red. So X is the variable that gives what? X is the variable that gives what? The number of yellow balls. So what happens in the first branch? How many yellow balls are there? 0. So X equals 0 is one probability. So you understand? How do you get the probability of along this particular branch? In this particular branch, X is 0. First of all, get this. In the first branch, do you understand X is 0? Because the number of yellow balls recorded in that particular branch is 0. Okay, what about the second branch? Tell me what's the X value in this branch? What is the X value in this branch? Look, red, yellow, red. How many yellows do we record? 1. X equal 1. In the third branch, tell me how many yellows do we record? Red, yellow, yellow. So I have 2 yellows. X is 2. Do you realize? In the fourth branch, what's the X value? How many reds? How many yellows do we record? Yellow, red, red. So we get 1. In the next one, yellow, red, yellow. How many yellows are we recording? Listen to this properly. So what do we get here? Yellow. How many yellows are there? 2. In the next branch, yellow, yellow, red. How many yellow balls are there in yellow, yellow, red? 2. X is 2. In the last branch, yellow, yellow, yellow. Everyone is yellow, which means X is 3. Do you see? So what are your X values? Your X values are between 0, 1, 2 and 3. So when you make a probability distribution, do you see what's going on? X equals 0 is one branch. X equals 1. Then X equals 2. Then X equals to 3. Okay, so when X equals 0, we have only one branch where X is 0, right? Which means I can directly write the probability of that branch. What's the probability when X is 0? You have to multiply the branch. The respective branch is 2 over 3 into 4 over 5 into 8 over 8. What's the answer? Quickly simplify and give me the answer. What's the answer we have? 8 over 8 is 1. 8 over 15. So when X equals 1, I think you can see when X equals 1, I have multiple branches, right? There are 2 branches, 2 over 3 into 1 over 5, 2 over 3, 1 over 5 into 7 over 8. That is one branch. Adding with the other one, 1 over 3, X equal 1 over 3, 4 over 5 into 7 over 8. You see? Multiply and tell me the answer. Two over 3 into 1 over 5 into 7 over 8 plus 1 over 3 into 4/5 into 7/8 gives me 7/20. Is that correct? And x equal to, and if x equal to, we have 3 branches. Do you see? I'm not going to go for x equal to. You know what I'll do? I'll go for x equal 3. I'll go for x equal 3. It's very easy to find x equal 3 because it's just one branch, isn't it? And then I can find x equals 2 by subtracting these probabilities. Because in a probability distribution, total probability must add up to 1. Okay? So let's get the probability x equals 3. That's the easiest. When x equals 3, I get here 1/3 into 1/5 into 1/4. How much is the answer? 1/60. Now add all these probabilities and subtract from 1. That's the easiest way to get it. 8/15. So 1 minus 9/10 should give me 1/10. Okay, so this is my probability distribution. Do you understand? This is the probability distribution for the value of x, which is the number of yellow balls that you record in the experiment. Okay, then they say find ex. Part E is to find ex, so we can easily do it, right? How do we find ex? You multiply what? You multiply the x value with its respective probability. 0 into 8/15 plus 1 into 7/20 2 into 1/10 3 into 1/60. How much is it? Multiplying by 0, of course, is giving you the same thing. The first one is 0 plus 7/20 plus 2 into 1/10 is 2/10 plus 3 into 1/60 is 3/60. So I get 3/5 or 0.6. Ex is 3/5 or it is 0.6. Okay, is this clear with you all? I hope it's clear with everyone. Okay. Okay, question number 5. The discrete random variable y has the following probability distribution. So they've given you the y values -9, -5, 0, 5, 9. Okay. And here they've given you the probabilities are totally unknown probabilities here, right? So they are saying where Q, R, and U are the probabilities. Write down the value of expected value of y. Okay, how do we find the expected value of y? Now here they've given you completely unknown probabilities, right? So then can we find Ey by multiplying the y value with the respective probability? Normally we find expected value by taking the y value or the x value and multiplying it with its own respective probability. However, you can see here now the probabilities are all unknowns. So then Ey means what? Ey means the average y value, isn't it? It's your average y value. So how do I write down the average y value here? Now, do you see here the probabilities? Look at the way the probabilities are distributed. Look at the way your y values are distributed. Look at the way your probabilities are distributed. Do you see here your y values are going in some kind of an order? Now, -9, -5, 0, and +5, +9. Completely symmetric, right? The y values, and look at the probability values. On -9 and -5, I have QR probability. Again for 5, 9, again I have R here, and again here I have Q. Do you see this is symmetric? Do you see both the sides are completely symmetric? On this side behind 0 and after 0, the probability values and the x values are completely symmetric. So what's the average y value? What is your average y value? Your average y value is going to be the value, this y value, isn't it? The y value at the top, because this is the one that falls exactly in the middle. And on either side, the probabilities are also equal distributed. So then your mean is not going to go anywhere. So your mean Ey will directly be 0. I'm saying that because one reason I'm saying that is it's just 1 mark here. So you need to understand when it's just 1 mark, you can get your answer directly. So there has to be some kind of a direct way to get our answer. So here we get the answer Ey is this 0. This 0 over here is our answer. Because our y values are symmetrically distributed around 0, and those symmetrically distributed y values have the same probabilities around. 5 and minus 5 have the same probability, 9 and minus 9 also have the same probability. Okay, so therefore the mean value is the one that falls exactly in the middle. So it's going to be 0. This 0. Okay, is that okay? Next part, the cumulative distribution function of y is fy. Given that f naught is 19 over 30, show that the value of u is 4 over 15. Okay, so this is this is something quite simple. How do we get f naught? Now here capital F naught means what? Capital F naught means the cumulative probabilities. So how do we take the cumulative probabilities? For cumulative probabilities, I mean cumulative F naught will include each and every single y value here until where? Until 0. So all the y values, we add all the probabilities of the y values behind 0. So what are the y values we have behind 0? Minus 9, minus 5 and 0. So I add the probabilities of these three guys. So F naught will include the probability of minus 9, which is Q, of minus 5, which is R, and of 0, which is U. So F naught will include these three. Do you understand? So then F naught value is given to us as how much? Given that, it's given that F naught is 19 over 30. Is Q plus R plus U, they are asking us to find the value of U. So the next thing that I do to find the value here is what? What's the next thing that we can do? The next thing, what's the next and only thing that we can do? Can you see that we know, we do know that the sum of probabilities what? Adds up to 1, right? So Q plus R plus U plus Q plus R equals 1, isn't it? You add Q, R, U, R, Q, add everyone, it becomes 1. Q plus Q is 2Q. R plus R is 2R plus U equals 1. And then in here, I can take a 2 out. 2 times Q plus R plus U equals 1. Are you with me? I think from this earlier equation, you can see that I can find out like maybe Q plus R the subject. Look at this, Q plus R is equal to 19 over 30 minus U. Do you agree with my equation? I went back to the F naught equation and I replaced and I kind of made the Q plus R the subject here. So 19 over 30, the plus U goes as minus U. And now what can I do? I can substitute that answer for Q plus R over here. And that gives me the answer for U. So 2 times Q plus R is 19 over 30 minus U plus U equals 1. So 2 times 19 over 30 gives me how much? 19 over 15 minus 2 times U gives me minus 2U plus U equals 1. So that I get here minus 2U plus U is minus 1U. Minus 1U goes to the other side. So I'll take 19 over 15 stays here. The 1 comes here as minus 1. Minus 2U plus U is minus U, goes to the other side as plus U. 19 over 15 minus 1 is how much? 4 over 15 equals to U. So this is my U value. U value is 4 over 15, which is the show that. So we need to get it properly. We have to show the relevant steps to get our show that. Okay. Okay, part C. Given also that variance y equals 37, find the value of Q and the value of R. Okay, how do we find the value of Q and R? So they say you variance y. Okay, what can I get from variance y? Okay, how do we go about finding variance y? You know, variance y is equal to what? Variance y is equal to EY square minus EY whole thing square, right? Okay, so then basically shall we find the EY and the EY square? So EY we already found, right? Expected value of y we found to be what? 0 in the previous part. EY square should be found. So how do we find the EY square? Minus 9 square into Q plus minus 5 square into R And here 0 into u, it's not necessary. Again 5 square into r. And 9 square into q. Is that okay? So when we multiply here, I get here 81q plus 25r. There should be a plus here, right? Again plus 25r plus 81q. Is that okay? And then get the equation here. Okay, so how much do I get here? 162q plus 50r. Okay, so I get this for my EY square. The EY square value we can find here, isn't it? Because variance y is given as 37. So 37 equals EY square minus this part is 0 because we found this EY is 0 in part A, isn't it? So then I get here EY square is 37 equals to 162q plus 50r is one equation. The other equation that we can get is another one we can get from q plus r, isn't it? So we can get another equation from the earlier section. 19 over 30 minus u. So let's get that. 19 over 30 minus u is 4 over 15 equals to q plus r. So what do we get here? How much is this? How much is it? 11 over 30. So these are the two equations. Q plus r equal 11 over 30 and 162q plus 50r is 37. So you get those two equations and then attempt to solve it simultaneously, and you should get the value of q and r. So input the values, get me the answer. So input the values here. What do we get here? Substitute, you can substitute r is 11 over 30 minus q. (37 equals 162q plus 50 times r. R is 11 over 30 minus q. So this is the r value. Solve this equation, get the value of q and r. 15 to 11 over 30 is how much? 55. It can be simplified, right? 15 to 11 over 30 is 55 over 3 minus 50q. So 37 minus 55 over 3 equals 162 minus 50 is, simplify. How much is q? 37 minus 55 over 3 divided by 112. Q is 1 over 6. Input the q value as 1 over 6 and get the r. R equals 11 over 30 minus q. R equals how much? 1 over 5. Okay, so these are the two solutions for P and Q. For R and Q. Okay, then let's move on to the next part. Okay, part D. The coordinates of a point P are 12, y. The random variable D represents the length of OP. Okay, so what do you mean by the length? Now here, you have specific values for y, right? We have very specific values for y, which means these the x coordinate is 12, the y coordinate depends according to what we get at this point. Do you see? Y coordinate could be minus 9, it could be minus 5, it could be 0 or 5 or 9. These are the values we get for y coordinate. They say the random variable D represents the length of OP. Find the probability distribution of D. So now how do we get the length from the origin to any point? So let's say this is my point O and if this is my point P. how do I get the length OP? So P is 12 comma Y. How do I get the distance OP? It's basically Pythagoras theorem, right? Modulus. Or basically it's just Pythagoras theorem. This is 12. This distance is 12 while this is Y, right? So it's 12 square plus Y square root gives you the distance OP. Am I correct? Okay, now what I want to do is they want you to find the probability distribution of D means you have to find all the possible values of D. So then all the possible values of D, how does the value of D vary? This D is the OP length is the D. So how does this D vary? D varies with respect to Y. So input all these different Y values and see the D values that you get. So first value of Y is what? When Y is minus 9. When Y is minus 9, how much is D? How much is D when Y is D is 15? Okay, then the next one when Y is 5, right? Minus 5. $13. Next when Y is 0. Square plus 0 square root, it becomes 12. Next one when Y equals 5. Again, what? 13. I think you can see for Y equals 5 and Y equal plus 5, we get the same answer. And Y equal 9 and Y equal plus 9, we get the same answer. Do you see? Same. And why? Because basically the 9 plus 9 square and minus 9 square gives the same answer. Okay, so the answer for Y equal minus 9 and Y equal plus 9 are the same. The answer for Y equal minus 5 and Y equal plus 5 are the same. For Y equal 0, we get a separate answer. You can see I get 3 different lengths for D. So how do you make it probability distribution? Make the table for D. So what are the D values we have? Simple D. The variable values are given by simple D. What are the variable values we have? So probability capital D equals simple D. So values we have are 12, 13 and 15. Okay, so what's the probability of the distance becoming equal to 12? I think you can see for 12, I only had from one Y value, right? From Y equals 0. So from Y equals 0, the probability value is U. To get Y 0, the probability value is U. What was our U value? 4 over 15. So this answer is 4 over 15. The distance becomes 12. You get the distance 12 for Y value 0. When Y value is 0, the probability value was U, which is 4 over 15. Then again, for the distance 13, what are the Y values we get? The distance 13. Distance 13 we get from minus 5 and plus 5. So when Y is minus 5 plus 5, what are the probabilities? You get R and R. These are the two probabilities for Y to be minus 5 and plus 5. So what is the R value? R value is 1 over 5. So R and there's another R. R plus R means you get 2 over 5. Do you agree with me? And for 15 we get it by using Y is minus 9 or plus 9. So Y is minus 9 plus 9. The probability values are Q and Q for both. So how much is Q here? Q is 1 over 6. So add 1 over 6 plus 1 over 6, 2 over 6, which is 1 over 3. Okay, so you can, another way to check whether, you need to check whether your probability distribution is correct. Add all these 3 probabilities and make sure what it adds up to 1. If it adds up to 1, then what you've done is correct. Okay, because I found all these 3 probabilities manually by using the table. So when you add all the probabilities, the answer must be equal to 1. So it is equal to 1. So then this is correct. Okay. Is everything clear? Okay. Yeah. So just to give a quick idea about the table again. So they say here the random variable D represents the length of OP. So the length of OP means basically 12 comma y is your coordinate. They've given 12 comma y as the coordinate. The y values you get from the table above. So for the different values of y, we calculate the different distances. Okay, so I calculated these three distances, and then what we do here is for these three distances, we look at the respective y value who gives each distance. Now 12 is given by y value 0. So when y value is 0, the probability when y value was 0 is what is the probability for the distance to be 12. Because distance 12 comes when y is 0, which means the probability of distance being 12 is the same probability that you get for y to be 0. So this 4 over 15 was the probability that y becomes 0, which we found in the earlier part. And when the distance is 13, for distance to become 13, the y values be used for minus 5 and plus 5. So these for these two y values, you go to the respective probabilities of these two y values and you add them, because there are two different y values who gives you this particular length. So this particular length has two different y values who gives you this, who gives the length. Therefore, those two probabilities must be added. And also when it comes to y equals 15, there are two different y values who gives you the distance is 15. So I add the probabilities of those two values and I add the probabilities of those two y values and I get the answers 1 over 3. So when, for example, when y is minus 9 and plus 9, the respective probabilities are q and q for both minus 9 and plus 9. So because of that, I add those two probabilities and I write it over here, because for the distance to be 50, the y values must be minus 9 or 9, and for the y value to be minus 9 or 9, the probability was what was given in the table. I have to take the probability of each respective column and add for both of these values. Okay, so that's how I fill this table, and definitely you should check whether this table adds up to 1, because that tells you whether the answer the table that you created, whether it's correct or not. Okay, so the for a probability distribution to be correct, accurate, the table, the total probabilities must add up to 1. Okay. Okay, last question. Siang is designing shelves for a bookshop. The height h centimeter of books is modeled by a normal distribution with mean 25.1 centimeter and standard deviation 5.5 centimeters. So once again, who is h? H is the height of the books in centimeters, right? Height of books in centimeters. And they say h follows a normal distribution with mean 25.1 and sigma is 5.5. So normally we put here the variance, sigma square, 5.5 square. So part A, they are asking you to show that the probability h is greater than 30.8 is equal to 0.15. Okay, how do we get this? Show that. First things first, convert what? When you have a normal distribution, first thing is we convert the normal distribution to standard normal distribution. So how do we convert to standard normal? H becomes z greater than, from 30.8 we subtract the mean. We subtract the mean and divide by the sigma. Sigma is 5.5. Okay, so from 30.8 we subtract the mean and divide by 5.5. So probability is greater than, how much is this value here? 30.8 minus 25.1 divided by 5.5. How much is it? or 55, 1.036. So we get something like this. So you can use probability z is greater than 1.03636. Okay, you get something like this. More figures in the calculus. Okay, so how do we get the answer now? So if you are using the table, or you can use your calculator, so anything is fine. Either go with the table or go with the calculator. Okay, so probability is greater than 1.03636. You could write this as what? 1 minus probability z is less than 1.03636. You could give this value. So you can get the value from the table. If you're taking from the table, you have to go for 1.04, right? 1.0, yeah, the closest value in the table. The table does not have this exactly, or else you can go with the cal. So in the statistics, you go for the options and you go for the normal distribution and the P. The P gives the probabilities behind. The Q gives the probabilities in front. So I go to P and I give this value 1.03636 and I get the answer 0.84998. Which gives me 1 minus of this is 0.15002, which is the closest is 0.15. Do you see? So it's a show that, and they've asked you to take it like that. Okay. Okay, part B. Siang decided that the smallest 5% of books and books taller than 30.8 centimeter would not be placed on the shelves. All the other books will be placed on the shelves. Okay. So we have the we have the normal. I mean, we know that the height of the books are normally distributed, and they're telling you that the smallest 5% of the books and the books taller than 30.8 would not be placed on the shelf. So they are asking find the range of heights of books that will be placed on the shelf. So what books are placed on the shelves? So when you take the normal distribution, so I think you can see H greater than 30.8. So the books, the mean here is 25.1, right? So this is the mean. So 30.8 is somewhere over here. So the books which are above 30.8, this probability is 0.15. So these books are not going to be placed in the shelves. Do you see? This particular percentage, this 15% of the books will not be placed on the shelf. And what other books are also not being placed? The smallest 5%. Where do you have the smallest 5%? The smallest 5% is at the other side corner, right? Do you see the smallest 5% is here? So in the smallest 5%, let's say this particular value is X. Okay, so they are saying the smallest 5% of books are also not placed on the shelf. So which books are placed on the shelf? The books that are between X and 30.8 will be placed on the shelves. So your task is to find X. How do we find X? Write the equation. So probability that your H is what? The easiest to say H is greater than or less than. Shall I go with less than? H is less than this X centimeter is what? 5%. The probability H is less than X is 5%. Then let's get the answer H less than. So what do you have to say here? X becomes X. Wait, let me convert to standard normal. Let's convert the whole thing to standard normal. Probability H less than, what do we get here? To convert to standard normal, H becomes Z. X minus the mean was 25.1 divided by 5.5. Are you with me? This is equal to 5%. So let's say this particular value is let's say this is Y or something. Just use some letter. So what do we know about this Y value? Is that less than Y is 5%? Is this Y? Now this is standard normal. In the standard normal graph, is this Y value a positive figure or a negative figure? Is this positive or negative? Definitely you can see this Y is what? This 25.1 is what becomes 0 in the standard normal distribution. This X is what I wrote as Y in the standard normal distribution, which means this Y is definitely negative. This is definitely negative. Okay, so this is a negative figure. Okay, so you realize that this is a negative in the standard normal graph. This is negative. So to make negative to positive, I taught you in the tutorial. I mean, we did earlier that to convert negative to positive. So I gave you a rule, right? Z less than minus A is equal to the probability Z greater than plus A. Isn't it? Do you remember this rule? Okay, so we did a certain number of rules regarding normal distribution. So Z less than minus Y is the same as the probability Z is greater than plus Y. So both of these probabilities are the same. So basically, what you can do now is, I think we can use not the first table in our standard normal graph, but the second table. Using the second table for 0.05, you can get me the Y value here. Who is the Y value in the second table? For this 5% area, they give you the Z value. How much is the Z value? 1.65 1.6449. So this y value is 1.6449 and your y value is a what y value? You know original y value is negative. So it's minus 1.6449. Replace y with the value that we use, x minus 25.1 over 5.5 equals minus 1.6449. Make x a subject, minus 1.6449 into 5.5 plus 25.1. Do you agree? X is how much? How much is it? Type in the cal, minus 1.6449 into 5.5 plus 25.1. How much? We get 16.05305. So basically, if I round it off, it's 16.1 centimeters. So basically, this is where the 16.1 centimeter is where the lowest 5% of books start. Lowest 5% of books are below 16.1. So what are the books we are keeping on the shelf? Books on the shelf. The heights of the books on the shelf. The height ranges are between where to where? Books on the shelf are having a height range from 16.1 to the highest value was 30.8, right? From 16.1 to 30.8. So this is the range of the height of the books on the shelf. This is okay? Okay, let's move on to the next part. The books that will be placed on the shelves have heights classified as small, medium, or large. Okay, do you see what's happening here now? You all saw that we removed the smallest 5% of the books and the tallest 15% of the books were removed, right? So what range of books were placed on the shelves? The books that are inside this range, right? Bigger than, what was this x value? 16.1, larger than 16.1 and lesser than 30.8. So these are the books that are falling onto the shelf, that go on the shelf. They say here, the shelves are also classified as what? Small, medium and large. Then they say find the range of, they say the number of small, medium and large books are in the ratios 2 to 3 to 3. So do you see what's going on? First of all, tell me what probability of books are falling inside the shelves. What's the total probability? Here you have 0.15, here you have 5%. So 0.15 is another way of saying what? 15%, right? 15% and 5% means altogether you have 20% of the books are not on the shelves. So what percentage of the books are on the shelves then? 80%. So that 80% is what happening. That 80% is divided in the ratio 2 to 3 to 3. Do you understand? So what's the ratio of the, so in part C, what's the probability of small? 2 to 3, can you divide your 80% in 2, 3, 3? So this is 3, 4, 5, 6, 7. Actually, you can see there are totally 8 parts, right? So is it difficult to break this up? Is it difficult to break it up? Now you know the books in the shelf, all the books that are in the shelf, they come inside this range, which is 80%. Are you with me? So this 80% is divided in the ratio 2 to 3 to 3. When you add 2, 3, 3, do you see the just how many parts? There are 8 parts, which means what's the value of one part? The total thing is 80%. So one part will be 10%. Common sense, right? So which means these 2 parts will be 20%. These 3 parts here for medium is 30%, and these 3 parts for the large will be again 30%, which means this 80% area I'm going to break it into 3. Do you get what's going on here? So let me draw it here. So in part C, okay, so in this part, the smallest 5%, and the largest what? 15%. These are not placed on the shelf. These are not placed on the shelf. So this remaining 80% is what's placed on the shelf. And that also we divide in the ratio. With that also we divide in the ratio 2 to 3 to 3. So when I divide 80% in the ratio 2 to 3 to 3, there are 8 parts, which means each part becomes 10%. Thereby what? The small region has how much? 20%, right? Are you with me? The small region is, this is the small. This has 20% of the area. And then the medium region has how much? 30% of the area. And the large region has how much? Another 30% of the area. Do you realize what's going on here? 2 to 3 to 3, how I divide the ratios, how I divide the area. The 80% area was divided in the ratio. So then I got 20% for small, 30% for medium, 30% for large. Okay. The medium books have heights x centimeters where x is between m and d. So here the x value, that means they are giving you the range for the medium. Do you see this medium books? So medium books are between the values of what? M and D. So these are the real heights of the books. Are you all with me? So they are saying the medium books are in the range M and D. I think we know already the other two ranges. This range we got was 16.1. This range was given as 30.8, right? Do you see? So the medium range is in between M and D. They are asking, show that D equal 25.8 to 1 dp. Okay, how do I find the value of this D? Tell me what's the easiest way to find the value of D? What is the easiest way to find the value of D? Take the area in front of D. What's the area in front of D? Completely. If you take the area completely in front of D, what do we have? We have 45%. And if you look at the normal distribution, the second table, don't we have 0.45 area? Okay. Take the full area in front of D so that we can use the table. We can use the second table. In the second table in normal distribution, don't we have 0.45? No. Okay, anyway, then we'll go with what we have. Okay. So anyway, the easiest then we'll go behind. Yeah, we'll go with the behind area. Okay. Okay, so since 0.45 is not there in the second table, we'll go with the area behind. Shall we? So what's the total area behind? So probability what? The H is less than D is how much? The probability H is less than D is how much? Add all the probability, it's how much? 55%. Do you see 30%, 20%, 5%? 55%. Do you understand? I'm taking the areas behind. I'm erasing these lines now. So probability H is less than D value is 55%. Are you with me? Let's convert the H to Z. So Z, this becomes D minus the mean value was how much? 25.1, right? Divide by standard deviation is 5.5 equals 55% is 0.55. Are you with me? So let's convert this value into, let's just write this as A. So I'm using A instead of D minus 25.1 over 5.5. So what do you have to say about this A? Is it positive or negative? So you can see the area behind A is how much? It's 55%, right? If the area behind A is 55%, is this a positive way or negative way? It's a positive way. This is definitely positive. Now take the first table. Go for the closest value you can get with probability 0.55. What's the A value? What's the A value that we can get closest to 0.55 from the first table? Okay, so this is the probability value you need to consider here. So I have taken the probability table, the normal distribution table, the Z value and the phi Z value is given. So we had the, we need to find the A value here. Our A value is over here. The area behind this particular value is, we got the area behind as how much? 0.55. The area behind is 0.55. Your task is to find the Z value. Basically, the phi Z value is given to you. You have to find the A value. So 5z value is 0.55. So remember the area. It's the second column they've given you. So 0.55, I don't have it exactly. So take the closest value. So what's the closest I have to 0.55? So there is 0.5478 and 0.5517. I think the closest to 0.55 out of 0.5478 and 5517 is 0.5517. Do you see? 0.5517 is the closest we can get to 0.55. So take that value. The z value is how much? Then the z value we take is, the a value we take is how much? 0.13. So take your a value as 0.13 from the table. Now let's proceed with the calculation. So a value was 0.13, positive 0.13. Okay, so a equals to d minus 25.1 over 5.5 equals 0.13. D equals to 0.13 multiplied by 5.5, adding the 25.1. How much do we get? Do we get the show that? They ask us to get a show that here, right? So it's 0.13 into 5.5 plus 25.1 gives me 25.815. Is it to show that? Yeah, 25.8 to 1 dp. 25.815. So correct to 1 dp, it's 25.8. Do you realize what's going on here? Okay, then the next part, they ask us to also find what? They ask us to also find the value of m. Shall we find the value of m as well? So looking at this is C Roman number 1. We have to do C Roman number 2. How do I find the value of m? Can you all tell me a similar expression to get m? Probability h is what? Do you want to go with less than or greater than? What is easier? So less than, I think we have 25%, right? The probability that if you take the area lesser than m, it's 25%. I think 25% we can go with the second table in the normal distribution. Okay, so probability h is less than m is equal to 25%. Are you with me? And definitely you can see when you make it standard normal, this will go to the negative side, isn't it? So probability, this is z less than m minus 25.1 over what's our standard deviation, 5.5 equals 25%, 0.25. So let me say that z less than b. Let's take this as b. And what do we have to say about this b? So when the area behind you is 0.25, it's a positive b or a negative b in the standard normal graph. In the standard normal graph, this is 0. So if b area less than b is to be 0.25, it's an area that's less than half. That means b is definitely not positive, b is definitely negative. B is less than z less than b area is 0.25. 0.25 is a really small area, less than half the area, so it should be negative. So then this is a negative b, which means probability you identify your z is negative. So z less than negative b is the same as z greater than positive b. So z less than negative b is the same as you would get for z greater than positive b. This area is also 0.25. Get the normal distribution. Okay, so then let's take the table. I think when we go to the second table, it gives you the areas in front. Okay, in the second table, it gives you the areas in front. So what happens here? I think when I take, I want the area in front. So we want the area in front to be 0.25. So you can see here the probability value. Yes, we don't have 0.25. We have 0.025, which means what? Which means what? We need to go to the first table. So we will need to go to the first table. Shall we go to the first table? In the first table, that means I'm not going to get the greater than area. I'm going to get the less than area. So z greater than b, in other words, is 1 minus probability z is less than b. Okay, so let's get this value. Okay, so then this probability is equal to what? Let me change it again. So this is all equal to 0.25. So 1 minus probability z greater than b is 1 minus probability z is less than b equals to 0.25. So I have done a revision. I have done a video on the S1 normal distribution. So first check it out before you, if you need to revise on the normal distribution. Okay, so then we'll continue on this. 1 minus 0.25 equals probability Z is less than B. So this is 0.75 equals probability Z is less than B, which is we take from the first table, right? So 0.75, get the area, the phi Z value should be 0.75. So what's the closest we can get to 0.75? 75177486. So the closest I think we get is 0.67, right? 7486 has a gap of 14, while this has a gap of 17, 7517. So 0.67 is the closest, isn't it? So then your B value is what? 0.67. And what 0.67? Remember your B is what? We identified from the beginning. Our B is negative. We identified from the beginning that our B is negative. So then let's input the values here. B is m minus 25.1 over 5.5 equals minus 0.67. What do we get for m? Minus 0.67 into 5.5 plus 25.1. Can I have the answer here? 21.415, which when you round off, it's 21.4. So this is the value of m in the medium books. This is okay. Last part. Siang wants 2 shelves for small books, 3 shelves for medium books, and 3 shelves for large books. These shelves will be placed one above the other, one above another, and made of wood that is 1 centimeter thick. Work out the minimum total height needed. Okay. So what's the minimum total height that you need? The first thing you need to realize is the small books have a height until m, right? So you need to realize small books fall into the height range 16.1 to m. It means the small books have a height of m. How much is m? We found m to be how much? We found m to be 21.4 centimeters. So if you want to put small books, the bookshelf needs to have a height of 24.1. And if you want to have the shelf that contains the medium books should have a height of at least d, isn't it? Should have a height of d. Okay, at most d actually. So d value we found as 25.8. So the medium books are between m and d. So the d value is 25.8. Okay, so then your medium books need to be, the medium shelf needs to be having this 25.8 centimeter height. Okay, and then your for the large books, the large shelf should have a height of how much? 30.8 centimeters at least. Okay, so then let's see how we can find the minimum height. So we are going to place each shelf on top of each other. The important thing you need to realize here is for the small books, it needs to have a height. The shelf needs to have a height of m. For the medium books, the shelf needs to have a height of d to fit the small books. And for the large books, your shelf needs to have a height of 30.8 to contain the large book. So they are all kept on top of each other. So what happens? You have this table. So you have the ground. Say you have the first one is what? You have the small. So you have 2 small shelves. Then you have the 3 medium ones, right? And then you have the 3 large ones. Okay, so then they want the height of this shelf, the minimum height. Now you know the small shelf has a height of how much? 21.4. So both of these small ones are 21.4. Medium has a height of how much? The biggest height we can get for medium was 25.8, the D value. So these are all 25.8. The large one has a height of 30.8. So all these 3 shelves are 30.8. Are you with me? And they also say that each shelf has a thickness of how much? 1 centimeter. So that means here in each and every intersection here is 1 centimeter thick. How many such 1 centimeter thickness lines do we have here? 1, 2, 3, 4, 5, 6, 7. And what about this one over here? At the bottom also is 1 centimeter. So we have 8. So let's add everything up. So what's the minimum height? So for height, you have 2 times 21.4 plus 3 times 25.8 plus 3 times 30.8. In addition to that, the thickness you have the 8 centimeters. So add everything. How much do you get? So the answer is equal to 220.6 what? Centimeters. Okay. So I hope all of you clearly understood how this works. So this is the end of the October 2021 S1 paper discussion.